Let's look at a few examples of hyperbolas that are not centered at the origin. So for each of these examples, we either want to write out the standard equation or sketch its graph, and then we want to list out all of its key characteristics. So that would include its center, its vertices, which there will be two of them, the foci, which there will also be two of them. And remember, the center, the vertices, and the foci are all going to be in the same line, either a vertical line or horizontal line. We want to find the length of the transverse axis, and then we want to find the equations of the asymptotes. Okay, so this first example here, we are given a hyperbola by graph. And so we need to first determine, is it a horizontal or a vertical hyperbola? And then we can figure out all of its key characteristics. So just looking at the graph, we see two curves. If you kind of thought of them as two parabolas, they are both opening to the left and to the right, one to the left, one to the right. And so that means that we have a horizontal hyperbola. So this is a horizontally oriented hyperbola. And if it is oriented horizontally, then the standard equation is going to be x minus h squared over a squared minus y minus k, quantity squared over b squared, is equal to 1. So to write out the equation for that, we would need to figure out the center, the h and the k values, and then we'd also need to figure out the a and the b values. Okay. And then if we want to figure out all the other values, all the foci, we also need the a and the b and the h and the k. We need all those values. So let's start by trying to figure out the values for a, b, and c. So a is the distance from the center to each vertex, and the vertices are the 2 points that are closest to each other. So looking at this graph, again, we have two curves opening away from each other to the left and to the right. And the closest 2 points between these curves would be at negative 1, 1. So at negative 1, 1. And then at negative 5, 1. Okay. So those are the two vertices. Those are the points that are closest to each other. And the length of the transverse axis is the distance between those 2 points. Half of that transverse axis is A. So how far is it from the center? Where's the center at? We can kind of see where the asymptotes intersect at the point negative 3, 1. So how far is it from negative 3 to negative 5, or from negative 3 to negative 1? That's a distance of 2. So the A value is 2. Okay. The B value, which is not as easy to see, but the B value would be from the center to the top or the bottom of this rectangular box, which thankfully we've been given this rectangular box. You may not always be given that, but so in this case, from the middle, from the center up to the top, is the distance of 1, 2, 3, 4. So the B value is 4. So that rectangular box is 4 units wide and 8 units tall. Okay, 4 wide, 8 tall. So how do we find C? So again, C squared is equal to A squared plus B squared. C squared is going to equal 4 plus 16, which means C squared equals 20. And C is going to be the square root of 20. And 20 is a 4 times a 5. So we could say C is going to be a 2 square root of 5. Okay. And we already know the center. So let's list out all the values we need. We need the center. We need the vertices. We need the foci. We need the transverse axis. And then we want the asymptotes. Okay. And we'll write the equation while we're at this. So the center, again, that's right where the two asymptotes meet, which is at the point negative 3, 1. So my center is -3, 1. The vertices are going to be, because this is a horizontal hyperbola, the vertices are going to be to the left and to the right. So I only need to change the x values. And the distance from the center to each vertices is measured by the value of a, which is a 2. So I need to add and subtract a 2 to the -3, the x value. So 2 units to the left of -3 would be a -5. So -5, 1 is one vertex. The other would be to the right. So 2 units to the right of -3 would be at a -1. So -1, 1 would be the other vertex, which we already saw that on the graph. So we already picked that up. We're going to do the same thing with the foci. So again, the foci, because it's a horizontal graph, they're going to be to the left and to the right, which only affects the x values. So it's going to be a -3 minus a 2 square root of 5, 1. And it's going to be a -3 plus a 2 square root of 5, 1. And again, I'm only adding the c value, that 2 square root of 5. I'm only adding it to the x coordinate because we're moving horizontally, because it's a horizontal hyperbola. The length of the transverse axis, we've already seen this, but it's the distance from one vertex to the other, and that's a distance of 4. And then for the asymptotes, so let's start with the slope. Rise over run. I know the box from the center is 4 units up and 2 units to the right. So the slope of that would be rise over run, so 4 over 2, which reduces down to a 2. And again, technically that is a plus or minus 2. So finding the equations for the asymptotes is a little harder this time because the center is not at the origin. So we do have a y-intercept. So to find the equation of the lines, we want to use point slope. So y minus y1 is equal to m times x minus x1. So I need to plug in a coordinate, an x and y coordinate for the x1 and the y1, and then I need to plug in the slope. Well, the coordinate that we're going to use is our center, because I know that both of the lines pass through the center. And then the slope, I have to do it once with the positive slope and again with the negative slope. So if we take our center, we're going to have y minus 1 is equal to a positive 2 times x plus 3. So y minus 1, because the y coordinate's 1, x plus 3, because the x coordinate is a -3. And I'm using the positive 2 for my slope here. So if we just reduce that, we're going to have y minus 1 is equal to 2x plus 6, which means y is equal to 2x plus 7. Do the same thing, but using the negative slope. So y minus 1 is equal to a -2 times x plus 3. Y minus 1 is equal to a -2x minus 6, which means y is equal to a -2x minus 5. So these are the two asymptotes that I would have. And just look at the graph just to double check that we get them. For the positive slope, it goes up 2 for every one it goes over, and it passes through the y-axis at 7. And the other line that's decreasing, and again, it goes down 2 over 1, down 2 over 1, and it passes through -5 on the y-axis. So our graph does match up. And maybe just last, again, let's write out what the equation for the hyperbola is. I know it's x minus h squared over a squared minus y minus k squared over b squared equals 1. So the h and the k is just the center. I know the a is 2 and the b is 4. So we're going to have x plus 3 squared over 4 minus y minus 1 squared over 16, and that is equal to 1. All right, let's look at a couple of more examples. This time we're given the equation, and then we want to go through and figure out all the key characteristics and then sketch the graph. So for our first example here, we have the equation y minus 1 squared divided by 16 minus x plus 3 squared divided by 25, and that's equal to 1. So let's start by first listing our A, B, and C values, and whichever one we don't have, we can find. So A is always the value under the positive fraction. So in this case, A squared has to be 16, so A is going to be 4. B squared has to be the other one. B squared has to be 25, which means B is 5. To find C, again, we can use C squared equals A squared plus B squared. So C squared will be 16 plus 25. So C squared is 41, and so C is the square root of 41. So now let's think about finding all of our key characteristics. So we need to find the center. We need to find the vertices, the foci, the length of the transverse axis, and then we need to find the equations for the asymptotes. And we also need to figure out, is this going to be a horizontal or a vertically oriented hyperbola? So looking at the equation, which variable is in the positive fraction? Well, it's y minus 1 squared over 16 minus, right, the x squared. So it's the y variable that's in the positive fraction. Y is a vertical variable. So this is a vertically oriented hyperbola. And we need to know that because that affects how we figure out the vertices and the foci and the asymptotes. So what is the center? The value with the x, we have x plus 3. So the x coordinate is a negative 3. For the y coordinate, we have a y minus 1 in the equation, which means it's going to be a positive 1. So my center is at negative 3, comma 1. The vertices, again, the vertices are always measured as a distance of A from the center. In this case, A is 4. So I need to be 4 units away from the center. And again, because it's a vertical hyperbola, that A value is going to change the y coordinate. So if I travel 4 units away from negative 3, comma 1, vertically, I'm going to end up at either negative 3, comma negative 3, or at negative 3, comma 5. Again, those are the 2 points that are 4 units vertically away from negative 3, 1. Same thing for the foci, but we're going to use the square root of 41. So I'm going to have a negative 3, comma 1 minus the square root of 41. And I'm going to have a negative 3, comma 1 plus the square root of 41. If you really wanted to know what those were as decimals, you could do that with the calculator. All right, the transverse axis is always the distance between the two vertices. It's also 2 times A. So in this case, A is 4. So double that, and you're going to get a length of transverse axis of 8. And again, that's also the distance between the two vertices. From negative 3 to 5 is a distance of 8. All right, so all that we need left to figure out here is the asymptotes. But before I do the asymptotes, let's switch over and try and draw the graph, and then we'll come back and we'll do the asymptote equations. So for the graph, I know my center is at negative 3, comma 1. So that's in the second quadrant. I know my vertices are negative 3, and negative 3, 5. Okay, and so I know that this is a vertically oriented hyperbola. So let's go ahead and put the little box inside here. So I know it has to be 4 units high from the center up 4 units and from the center down 4 units. The B value tells me how wide it is. From the center, 5 units to the left and 5 units to the right. So 1, 2, 3, 4, 5. So that's going to be, the right edge is going to be at x equals 2. And the left end edge is going to be, so from negative 3, 5 units to the left would be at a negative 8. The top is going to be at y equals 5, and the bottom is going to be at y equals a negative 3. And so we can draw our asymptotes kind of diagonally across each through the center, and then each corner, opposite corner of the box. And this is a vertical hyperbola. The vertices are at the top and the bottom of the box, and so the graph has to go through the vertices and then extend out towards the asymptotes. Okay, so something kind of like that. So to find the asymptotes, let's look at the slope. So I know from the center to the side of the box is a distance of 5 units, and from the center to the top of the box is 4 units. So that means the rise is 4, the run is 5. So the slope is going to be plus or minus 4/5. Okay, that's the slope of the asymptotes. We also want to find the equations of the asymptotes, and we'll do the same thing. We'll use that slope, point slope form, and we're going to use the center for the point. So we're going to have y minus 1 is equal to the slope, which is a negative 4/5 times x plus 3. So it's y minus 1 because the center has a y coordinate of 1. It's x plus 3 because the center had an x coordinate of negative 3. And I went ahead and used the negative slope this time. So the other equation is going to be y minus 1 equals a positive 4/5 times x plus 3. Okay, so those are what the two equations look like. If you don't want to do a whole lot of work, just solve them for y. So this first equation is going to be y equals a negative 4/5 times the quantity x plus 3, and then plus 1. And the second equation is going to be y equals a positive 4/5 times the quantity x plus 3, and then plus 1. So that's what they're going to look like. We can then just simplify. So y equals a negative 4/5 x minus 12/5 plus 1, which if you combine the negative 12/5 and a 1, you need a plus 5/5. So we're going to have y equals a negative 4/5 x minus 7/5. So that's going to be one of the asymptotes. The other y is going to equal 4/5 x plus 12/5 plus 1. And again, plus 1 is going to have to be plus 5/5. So y equals 4/5 x plus 17/5. And that's the other equation of the asymptote. All right, let's look at one more example here. This time, again, we're given the equation in more of the general form, so it's not factored the way we want it. So we need to start with that first. So let's factor this equation. We're going to need to use completing the square. So we need to group the x's together. We need to group the y's together, and then move any of the coefficients over to the other side. So let's group the x's first. So we'll have negative 4x squared plus 24x. Then we'll group the y's, which leaves us with plus 9y squared plus 90y. And then we're going to move the constant to the other side. So equals a negative 153. So I've taken a negative 4x squared plus 9y squared plus 24x plus 90y plus 153 equals 0. And I've grouped the x's, I've grouped the y's, and I've put the constant to the other side. Now we need to factor any leading coefficient for the squared terms. So x squared has a negative 4 in front of it, so I need to factor a negative 4 out of the x squared and the x term. So if I take the negative 4 away from the 4x squared, it becomes an x squared. If I factor a negative 4 out of the x term, so it has a positive 24. A positive 24 divided by a negative 4 is going to be a negative 6. So I have x squared minus a 6x with a negative 4 all out For the y terms, we're going to factor out a 9, and that leaves me with y squared plus 10y. And then that still equals a negative 153. Completing the square, we're going to have negative 4 times x squared minus 6x plus some number, plus 9 times y squared plus 10y plus another number, and that's going to equal a negative 153 plus two numbers, and we need to figure out what those are. Okay, so again, we're going to take 6 divided by 2 and square it. 6 divided by 2 is 3, so 3 squared is 9, and that's what we're going to add for the x's. For the y's, we're going to take 10 divided by 2 and square it. So 10 divided by 2 is 5. 5 squared is 25, so I need to add in a 25 for the y's. That's on the left side. Okay, so on the left side, I added a 9 in the x parentheses, but that 9 is being multiplied by negative 4. So I've really added in a negative 36 on the left side for the x's. And then for the y's, I have a plus 25 that's being multiplied by another 9. So 9 times 25 is going to be a 225. So on the right side, I should have a negative 153 plus a negative 36 plus 225. Okay, so when we complete the square, we're going to have a negative 4 times the quantity x minus 3 squared plus 9 times the quantity y plus 5 squared. And then if we combine all the terms on the right side, it will reduce down to just a 36. Again, for a hyperbola, we want it equal to 1, so I'm going to divide everything by a 36. And so 4 reduces with 36 9 times. So I'm going to have a negative x minus 3 squared over 9 plus the 9 and 36 reduced down to a 4. So y plus 5 squared over 4, and that's equal to 1. I could leave it like that, but usually we've always seen the positive fraction minus the negative fraction. So let me rewrite that real quick as y plus 5 squared over 4 minus x minus 3 squared over 9, and that'll equal 1. So that is the standard equation that we get from that general equation that we saw earlier. Okay, so after we complete the square, that's what we're going to see. Now, from this equation, we're going to see that a and b, right? We can get the a and b off the equation. The a is the value in the denominator, so a squared has to be a 4, which a is 2. B squared has to be 9, which means b is 3. We use c squared equals a squared plus b squared. So c squared is going to be 4 plus 9, and c squared is equal to 13. So c is going to be the square root of 13. Okay, so we know a, b, and c. We now need to figure out, is it a vertical or horizontal hyperbola, and then what are all of its key characteristics. So since the y variable is in the positive fraction, y is vertical. So again, this is going to be a vertical hyperbola. Okay, so once we know that, we can then look at finding the center, the vertices, the foci, the length of the transverse axis, and then the equations for the asymptotes. So the center, we have x minus 3, so the x coordinate is a positive 3. And then we have y plus 5, so the y coordinate is a negative 5. So my center is at 3 comma negative 5. The vertices are going to be a distance of 2 away from the center, because 2 is the a value. And it's vertical, so they're going to change the y coordinate. So I need to go 2 units above and 2 units below a 3, -5. So that would be 3, -7 and 3, -3. Those would be my vertices. Foci are going to do the same thing, but use the C value. So 3 and then -5 minus the square root of 13, and then 3, comma, -5 plus the square root of 13. The length of the transverse axis is 2 times whatever A is, which A is 2. 2 times 2 is 4. So the length of the transverse axis is 4. Let's do the graph first, then we'll come back and we'll look at the asymptotes. Okay, so I know the center is at 3, -5. The vertices are at 3, -7 and 3, -3. So again, those are 2 units away. And notice they're both vertically in the same vertical line as the center. Same thing would be true for the foci. The height of, we then want to draw the box. The height of the box from the center to the top and the center to the bottom is the value of A, which A is 2, which is where our vertices are. And then the width of the box is 3. So from the center to the right is 3, and the center to the left is 3. So that's going to tell me, so I guess technically the width of the box is double that. So the width of the box has a width of 6, and the height of the box is 4. And then we can go ahead and draw in our asymptotes, going diagonally through the center and the opposite corners of the boxes. Okay. So what is the slope for these asymptotes? Well, they rise 2, they go up 2 units, and they run 3 units. So the slope of my asymptotes is plus or minus 2/3. Okay, let's finish the graph and then we'll figure out the equation for those asymptotes. Again, the graph has to go through the vertex and then open up and down because it's vertical. And as it goes away from the vertex, it's going to start approaching those asymptotes. So we're going to go kind of to the left and to the right, both down as we go towards the asymptotes. And then we're going to see the same thing happening upwards. So it's going to go to the right and up and to the left and up. And it's going to go out along that asymptote there. All right, so let's just finish the equations for the asymptotes and we'll be done. We know that the slope is plus or minus 2/3. And we know the center is at 3, -5. So we're going to have y plus 5 is equal to a -2/3 times x minus 3. And then the other one is going to be y plus 5 equals a positive 2/3 times x minus 3. And again, it's plus or minus 2/3 because that's the slope of the asymptotes that we saw in our graph. And then we have y plus 5 in both equations because the center has a -5 y coordinate, and it's x minus 3 because the x coordinate was a positive 3. So we just need to simplify these equations. We could subtract 5 from both sides. So y equals a -2/3 times the quantity x minus 3, and then minus 5. We could also have y equals a positive 2/3 times the quantity x minus 3, and then minus 5. And in essence, that would be sufficient. I'm going to go ahead and write it in the y equals mx plus b form, though. So just a couple more steps for each equation. So we'll have, for the first equation, we'll have y equals a -2/3 x plus, if you take 2/3 times 3, the 3's cancel. So it's just actually going to be plus 2 and then minus 5. So y equals a -2/3 x minus 3. And then we do the other equation, y equals a positive 2/3 x minus 2 minus 5. So y equals a 2/3 x minus 7.